Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. So now we are on mean and standard deviation, lecture number 4. And let's do some questions which are of the basic type. Maybe there are some with the unknown. Maybe there are some in which there is combination. Maybe there are some which is about coding and so on. So let's look at the first question. The first question says a sample of 36 data values. Let me do some underlining. A sample of 36 data values gave sigma x minus 45 as this much, sigma x minus 45 whole square is this much. Find the mean and standard deviation of the 36 values. So the first part is simple, basic stuff. So part one, and this is let y equals to x minus 45. This is a basic coding question. Therefore, sigma y, that is equals to negative 148, and sigma y square, that is 3089. And let's calculate y bar, that is sigma y over n. And I need 2-3 volunteers from the people who are sitting at home so that they can use the calculator and I can comfortably work it out. So my WhatsApp is also open. And then this is negative 148 divided by how many there are? 36. So give me this value first. And then let's calculate the standard deviation of y. So S dy whole square, that is sigma y square over n minus y bar square. That is 3089 over 36 minus this value is negative 4.111. Negative 4.111, thank you, square. Evaluate this thing, that is S dy square. And they're asking for standard deviation. So standard deviation of y would be square root of this thing. Your answer will be given first correct to 4SF minimum, and then standard deviation of y would be 3SF. So now I'm waiting for something. Okay. So the very final answer, someone gave me 8.30. Is that the very, very final answer? Yes, that's the very final answer. So this is, I think, is it the same question? 45 minus? I think so. So 8.30, that is the final answer, 3SF. And minus 148 over 36, that is negative 4.111. Now they want standard deviation for x. So therefore, y is x minus 45. Y bar is x bar minus 45. Y bar is negative 4.111 is x bar minus 45. Make x bar the subject, that is 45 plus negative 4.111. After the subtraction, this is x bar, that would be 40 point something. 40 point something, that is coming out to be somewhere, it should be written over here, which I cannot see for some reason. So this is mean is 40.9. So 40.9 correct to 3SF. This is done. And standard deviation of x is the same thing as standard deviation of y. Standard deviation of x is 8.30 correct to 3 significant figures. So now if you want complete full marks, you should work with the final answer in 3SF. The first thing is done and dusted. So let me copy this thing and let me paste it on the next page. Okay. So now it says the second part. It says one extra value. So now we have done questions in which something was subtracted. Now this is being added. So part two, this is coding plus addition. So now it says one extra value of 29 was added to the sample. Find the standard deviation of all 37 values. So now sigma x minus 45, the new thing, that should be sigma x minus 45, the old one, plus this value 29, and from 29 subtract 45. That is one approach. So the old value is negative 148 plus 29 minus 45, give me this value. Now you can calculate, let y equals to x minus 45. Sigma y is how much? That is negative 164. And n is now 36 plus 1, which is 37. Y bar is negative 164 over 37. Don't give me this value as yet. Let me write it down. Y is equals to x minus 45. Y bar is x bar minus 45 minus 164 over 37 is x bar minus 45. Hence, we make x bar the subject. That is 45 plus negative 164 over 37. Now give me the new value, first in 4SF and then x bar as 3SF. So only one person is giving me the answer. There could be more, and that person can give me the answer. Yes, there are 2, 3 more. That's good. Okay. 40.56. So 40.56, and that is 40.6. No harm in double checking. They are interested in the standard deviation. So let's focus on the standard deviation. That's one thing. Now, what else is there? Sigma x minus 45 whole square new should be sigma x minus 45 whole square old plus 29 minus 45, the whole thing square. So this is 3089 plus 29 minus 45 whole square. Give me this value. Okay. $256 and 3345. How is it 256? 3345 makes sense. 3345, that makes sense. And standard deviation of y whole square, that is sigma y square over n minus y bar square. That is 3345 over 37 minus negative 164 over 37 whole square. Give me this value with the square. Then give me the y value without the square. STY 4SF, STY 3SF. Okay. 70.75 and without square root, 70.75, 70.75 with the square root. Okay. 8.411 and 8.41, that is 3SF. So standard deviation of y is the same thing as standard deviation of x. 8.41 is the answer. So whoever is doing the working right now, they are preparing themselves in a very good manner for the exam. Okay, so now this first question is done and dusted. 3 plus 4, 7 mark. So now this question, question 12, that was about basic coding. And that was about adding a value. And I hope this is all good, all clear in a very easy manner. What is this about? This is oranges, this is lemons. Let's look at the question. So now this is about oranges. And this question is about lemons. So let's get started. This is about combination. So this is about combination of two sets of data. So let's read the question first. Now the question says, Barry weighs 20 oranges and 25 lemons. For the oranges, the mean weight is 220 and the standard deviation is this much. So let me write it out. So first of all, for oranges, the mean weight X bar for oranges is 220. Standard deviation for oranges is 32. And for the lemons, the mean weight X bar for lemon is 118. And the standard deviation for lemon, that is 12. Find the mean weight of the 45 fruits. First of all, X bar for oranges, it's sigma X for oranges divided by number of oranges. And first of all, how many oranges are there? There are 20 oranges and 25 lemons. Number of oranges, 20. And number of lemons, 25. And let me just take this down. And let me put it in a box. Okay, this is the data that's given, and this is the working that we are doing. So now sigma X oranges, that is this and this multiplying together, this and this multiplying together, that is 220 into 20. Don't give me the value as of now. I'll just ask for it very soon. X bar for lemon, that is sigma X for lemon divided by number of lemon. And let me just write, not such a big one. This is ST. So multiply these two. Sigma X for lemon, that is XL and 25, 118 into 25. Therefore, sigma X for the group, that is sigma X for oranges, sigma X for lemon, and X bar for the group, that is 220 into 20, that is this thing, 118 over 25, divided by 20 plus 25. Now give me the value 4SF. Now give me the value 3SF. So I think this is going to be exact. I think this answer is 163. This answer is 163.3. Therefore, 163, that is 3SF. It's not exact, but that is what you're getting. That is the first basic thing. Let's move to the next page. Now, it further says the first thing is done and dusted. Now let's focus on this. The individual weights of oranges is denoted by X naught. Individual weights of lemon is denoted by XL. By first finding sigma X square for orange, sigma X square for lemon, find the variance of the weights of 45 fruits. So they're interested in variance, not standard deviation. And we have done questions like this before. So nothing special. Let me pick this thing up. And let me paste it over here so that you have the data intact. Okay. Now let's use the standard deviation formula. Standard deviation orange square sigma X square for orange number of orange minus X bar orange square. Therefore, SD orange square X bar orange square, put it in a bracket, number of oranges, sigma X square for orange. The same thing over here. Standard deviation for lemon square, X bar for lemon square, put it inside a bracket, number of lemon, that is sigma X square for lemon. So now this is 220, first of all, 32 square. X bar, that is 220 square. Inside the bracket, number 20, this is sigma XO square. Give me this value, sigma XO square. exact value. This one is 12 square. X bar is 118 square into 25. This is sigma XL square. Give me also this value. So this is sigma XL square. That is the other value. So now the first value is coming out to be 988480. 988480. What is the second value? 351700. 351700. Sigma x square for the group, that is 988480 plus 351700. And then SD square for the group, that is sigma x square for G divided by number of G minus x bar of G square. So this is how much? I'm just waiting for this. Or you can just put it in the calculator. 988480351 divided by 45 minus x bar. How much was the x bar overall? 163.3. That is 163.3 square and SDG square. I'll just pick the answer from here. This is 1340180. 1340180. And then the final answer is 30, between 3100 and 3120. So now this is just waiting for you people. So 3114.88. 3114.88. So basically 1, 2, 3, that's fourth significant figure. So therefore, I can write this thing as 3110 correct to 3SF. Okay. So basically, I have changed it, and that is the final answer. They are saying that the answer could lie in this range. So it's perfectly fine. So now this thing is also done. This is about combination. Now let's look at this question. They are not asking for standard deviation. They were not asking for standard deviation. They only asked for variance. So also always make a habit of reading the question. Now, what is this question all about? This is not about coding. This is about the two formulas for standard deviation. Formula 1 for standard deviation square, that is sigma x square over n minus x bar square. Other formula for standard deviation, that is sigma x minus x bar square over n. Now let's double check. What do we have? And we should also know that we know that x bar is sigma x over n. So now we have sigma x over here. We have n over here. We have sigma x square over here. Again, we have n over here. They are asking for sigma x minus x bar square. That is this thing. That is what they're asking. And again, the n is over there. I hope everything is there. So now let me write it. First of all, sigma x square. Sigma x square is 8287.5. 8287.5 divided by n, that is 150. Minus x bar, that is sigma x, which is 645 over 150 whole square. Equate it to sigma x minus x bar, sigma x minus x bar square over n. How much is n? That is 150. So now just evaluate, make it the subject, and hence you will be finding the value of sigma x minus x bar square. And again, 4SF and then 3SF. So this one is a usage of both formulas of standard deviation. So the square root is not written because that is the 1. So this is 5514. Let's double check. 5514 exact. So this is 5514. If it is exact, then you leave the answer as it is. No need of rounding off. No, if it's exact, then there is no rounding off. If it is inexact, then round it off. And we will talk about that thing in tomorrow's class. Something to do, not tomorrow's class. We will talk about it on Monday when we'll be starting with S1 past papers. Okay, now this thing is done. Another question of a similar type. So this is basically about coding and using the concept to find sigma x, using the concept to find sigma x square. That is again a basic kind of question. So now let's read it. There are 24 people. Its amount of money. The data is summarized. Let y is equals to x minus 36. Sigma y, negative 60. Sigma y square, 227.76. N is 24. Let's calculate y bar. That is negative 60 over 24. We know that y bar, y is x minus 36. Y bar is x bar minus 36. Negative 60 over 24 is x bar minus 36. X bar is 36 plus negative 60 over 24. How much is x bar? Waiting for the answer. And this is coming out to be... Okay. Y bar is negative 2.5. X bar is 33.5. X bar is 33.5. This is exact. And coincidentally, it's also 3SF. Now, they are not asking for mean. They're asking for sigma x. So now use the formula x bar is sigma x over n. 33.5 is sigma x over n. N is 24. So therefore, make sigma x the subject, 24 into 33.5. Sigma x is 804. No harm in double checking. That is how you're getting it. Now, of course, there are more than one ways of doing it. I'm just doing it in the very, very basic way. Now over here, what else is there? So we need to find sigma x squared. So write down two formulas, the same formula in both variables. S d y square, S d x square. They should be the same. So on the left hand side, if I write that is S d y square sigma y square over n minus y bar square. And on the right hand side, this is sigma x square over n minus x bar square. And let's equate it. Sigma y square, 227.76. N, 24. Y bar, negative 2.5. Sigma x square, that is what you're looking for. N, 24. X bar, that is 33.5 square. So therefore, 227.76 over 24 minus negative 2.5 square plus 33.5 square. Put it inside a bracket multiplied with 24. That is sigma x square. So sigma x square 4SF. Sigma x square 3SF. Final answer is 27011. I think so. It's an exact answer. 27011, 27011.76, 27011.76. If it's not exact, then you should round it off a little bit more. So that should be 27,000. Okay, so that is the exact answer, correct to 3SF. 27011, that is not 3SF. If it's inexact, you have to round it off. So question number 18, coding sigma x squared, that is done and dusted. Now this question, the first part, we did it in class. And I said second part, we will do it later. So now I think we are going at a very regular pace. It's time for you people to try it out. Take around like 6-7 minutes. I'll pause the recording. First try it out, then I'll solve the question. Everyone. So now people, let's look at this question. The question says, Asmi noted the test marks X of 16 people in a class. So X is test marks. She found that sigma X is this, and the standard deviation was 6.5. Calculate sigma X minus 50, sigma X minus 50 whole square. Now, first thing first, that is this thing. Now we have sigma X is 824. There are 16 people altogether, and from each value, 50 is subtracted. So 16 into 50, that is 800. That means sigma x minus 50 is 824 minus 800. That comes out to be 24. That is the simplest way of doing this calculation. What about this part? Sigma x minus 50 whole square. Let y is equals to x minus 50. So basically, we know that standard deviation of x is the same thing as standard deviation of y. So standard deviation of y whole square, that is sigma y square over n minus y bar square. So we have, I can get y bar from here. Just hold for a second. And I'll write s dy square plus y bar square bracket, inside bracket multiplying with n, that is sigma y square. Now, how can I get y bar? So we know that this thing is sigma y. Sigma x minus 50 is basically sigma y, that is 24. N is how much? That is 16. Therefore, y bar is how much? 24 divided by 16 or 1.5. That's one way of doing it. Is there another way of doing it? Yes. We can calculate x bar. That is sigma x over n. That is the same thing as 824 divided by 16. Now, what is 824 over 16? So that is 824 divided by 16. That is 51.5. And let me take this thing down like this. And we know that y bar is x bar minus 50. Y bar is x bar, which is 51.5 minus 50. That comes out to be 1.5. So that is how you can get y bar. This is method 1 of getting y bar. This is method 2 of getting y bar. Now coming back to this thing. So let's grab this thing, slide it down like this. So now when I have to do the working, what are the things that I have? I have s dy square. S dy is 6.5. So 6.5 square. We know that s dx and s dy is the same. 6.5 square plus 1.5 square, put it inside a bracket, multiplied with 24. I think this answer will come out to be exact. So therefore, someone has given me this answer. This is coming out to be sigma y square. That is 712. That is an exact answer. And sigma y square is another way of writing sigma x minus 50 whole square. So I hope this first thing is all good, all clear. Now, again, the addition thing is there. Let me add this thing. Now let's focus on the second part. It says one person did the test later and her mark was 72. Calculate the new mean standard deviation of the marks of all 17 people. So now we have sigma x minus 50, that is 24. We have sigma x minus 50 whole square is 712. One person is added, 72 marks is added. So sigma x minus 50 is equals to 24 plus 72 is added, but 50 is subtracted because of this. So this is 22 plus 24, that is 46. Similarly, sigma x minus 50 whole square, this is new. This is new. That is 712 plus 72 minus 50 whole square. And give me this value. That is 72 minus 50. That is 22. 22 square plus 712. That is coming out to be 1196. And now let's work it out. So therefore, y bar, this is sigma y, correct? That is sigma y over n, that is 46 over 17. And standard deviation square for y, that is sigma y square. This is sigma y square, that is coming up divided by n minus y bar square. So this is 1196 divided by 17 minus 46 over 17 whole square. Someone can use the calculator, SDY square, and then they can get SDY or SF, and then they can write SDY 3SF, and SDX is the same thing as SDY, and that is the answer. Over here, X bar is Y, sorry, let me make Y bar the subject. Y bar is X bar minus 50. Therefore, this is 46 over 17 is X bar minus 50. Therefore, X bar, that is 50 plus 46 over 17. So now let me go to my WhatsApp. 1196, someone gave me that value. 63.04 for SF. So this is 63.04 for SF, and then 7.939. And hold for a second. Let me just remove this thing. Let me write this thing as 7.939 and 7.94. This is 7.94. All good? And this is the answer. I think that's only answer for part one for some reason. And the second thing is 50 plus 46 over 17. So 46 divided by 17, that is 2.70. 50 plus 2.70588, that is 50 plus 2.71. And this is 52.71, and that is 52.73 SF. So just double check my working. I hope this is all good, all clear. Okay, so now this thing is done. Let's move to the very last question. And again, I would like you people to try it out. Okay, let me just do it. So just to save time, let me do it. The values in X of a particular set of data is given. Let Y equals to X minus 25. This is sigma Y. This is sigma Y square. This is mean of X bar. The mean X bar is this thing. Now we know that Y bar is X bar minus 25. X bar is 28.325 minus 25. That is 3.325. This is Y bar. Okay. And what are they asking? They're asking for the standard deviation of X and find sigma X square. Now, why are they asking this? because they know that y bar is sigma y over n. Uh, have they given us n? No, they're looking for n. That is why this thing is asked. 3.325 is sigma y, which is 133 over n. Therefore, n is 133 divided by 3.325, that is exact 40. So now this is a question in which there was an unknown n. So that is why all this data is given and n is calculated. So all this working is technically for part one, but in part one, find n first, and then we can talk about standard deviation. So now the part is still continued. St y square, that is sigma y square over n minus y bar square. Sigma y square is 3762, 3762. Let me just double check, 3762. Got divided by 40 minus y bar is 3.325 square. Sty square, you will get this value. Sty, you will get this value, 4sf. Sty, you will get this value, 3sf. And then sdx is sdy, that is this value. So now 9.11, final answer, 9.11, 9.113SF, that's the final answer. 9.11, there it is. That is the final answer. Now the second part is there. Let me capture this thing. Let me move to the next page. And let me focus on the last one. As usual, that is sigma x square. So now sdy square should be sdx square. Sigma y square over n minus y bar square, sigma x square over n minus x bar square. Sigma y square over n minus y bar square plus x bar square, the whole thing in bracket multiplied with n, that should be sigma x square. So this time I worked in symbols. I took this over there. Once that is done, then I multiplied with n. So now what do we have? Sigma y square is 3762, 3762 divided by 40 minus 3.325 square. How much is x bar? X bar is this thing, 28.325, 28.325 square. Make a big bracket multiplying with 40, that is sigma x square. It's all algebraic calculation, and sigma x square should be exact 35412. That is 35412. This is exact. There is no rounding off. Why is there no rounding off? Because this was exact. This was exact. And I hope so. 3762 over this thing, that is also exact. So make a habit of double check. So therefore, the final answer is exact, no rounding off. So I hope this is all good, all clear. And I'm signing off for mean, standard deviation, coding, and a lot of other stuff. So stay tuned for more math content on mathematics with Shahab Yaqub. Take care, everyone.